Alright, so we're looking at question 14 on the MAC 1140 Pre-Calculus Final Exam Review. It's asking us to solve the rational inequality and express the solutions at an interval notation. So looking at a rational inequality, we have negative x plus 7 divided by x minus 2 is greater than or equal to 0. So our first step is going to be taking our numerator and setting it greater than or equal to 0, and then our denominator is going to be set equal to 0, not the greater than part. So we're going to have x minus 2 is equal to 0. So now for both sets, we want to isolate that x. So I'm going to start with our first term, our numerator, and we're going to have minus 7 from both sides, which leaves us with negative x is greater than or equal to negative 7, divided by negative 1. And then remember, when you divide an inequality by a negative, it flips it. So this will become less than. So we're going to have x is less than or equal to positive 7. And then for our second term, which is our denominator, we're just going to likely add 2 to both sides, which is going to leave us with the restriction that x cannot equal positive 2. So once we have those, we can go ahead and graph these out on a number line so we can test where our solution set should be. So we're going to go ahead and graph negative infinity, positive infinity, and then 2 and 7. We're going to pick some numbers in between these. So I'm going to work with 0, and then I'm going to choose 5, and then 10. So when we work with these, we're going to treat these as our x values. We're going to plug each number. We're going to plug each number into our original rational equality wherever x is. So let's start with x is equal to 0. When we do that, we're going to get negative 0 plus 7, 0 minus 2. It's greater than or equal to 0. When we reduce that, we're going to be left with 7 divided by negative 2. It's greater than or equal to 0. And we know that this is a false statement because it yields a negative number. So we know that this portion right here is not true. Now moving on to our next number, x is equal to 5. We're going to be left with negative 5 plus 7 divided by 5 minus 2 is greater than or equal to 0. When we do the math, we're going to have 2 divided by 3 is greater than or equal to 0, and we know that this is a true statement. Now lastly, we have x is equal to 10. When we plug this one in, we're going to have negative 10 plus 7 is divided by 10 minus 2 is greater than or equal to 0. When we reduce it down, we'll have negative 3 divided by positive 8 is greater than or equal to 0. And this yields, again, a negative argument, so we know that this is false because a negative argument is not greater than 0. So now, to get our solution set, we're going to look at our number line that we just did. We can see that our argument is only true between 2 and 7. But we know that our solution set cannot contain 2, so this will be a parenthesis because it can't contain it. And since it's greater than or equal to, we know that 7 is going to be a bracket. So when we rewrite that, that's going to be a parenthesis, 2, 7, bracket. And that is our final answer.